Okay, we're going to look at some problems that I assigned toward the end of the lesson. Number 41 says passing up, you're supposed to write an equation in standard form, so they're being really picky about what form we put it in. And the problem is it goes through the origin, okay? So now you got to remember the origin is a point, it's 0, 0, so there's your point. By the way, that's a y-intercept. It's both an x-intercept and a y-intercept, but you know, that might be handy for me to remember that that's a y-intercept because I know one of my equations of lines uses intercepts, so that might be handy. And it has no slope. No slope means it's a vertical line. Basically, if I sketch this is a vertical line through 0, 0. So if here's 0, 0, a vertical line through 0, 0 would be, remember the form of a vertical line is always x equal the x-coordinate of the point you're going through. Well, what's the x-coordinate of this point over here? Oh, it's 0. Ah, there's my equation. So a vertical line is always x equal, it has no slope. And you see, it would have been hard for me to do this did I not know that a vertical line had no slope. And if I didn't know the equation of it. So that's something you've got to commit to memory if you haven't yet. If you have tried to learn it and understand it and you're still struggling with it, just go ahead and memorize it if you need to. But it's something that by now we need to have down. We'll look at number 43, and we may go as many as we can on the video. So 43 says it has a y-intercept of 6. Y-intercept. If I think about y equal mx plus b, that's my b right there, isn't it? So I'm just thinking of things as I get information in a problem. One of the things I do is try to think about, well, do I know a formula that has that in it? And if I do, I write it down just so that I see it in front of my face, and maybe my brain will make the connections a bit better. All right, it's parallel to the x-axis. Okay, let's look at that. Let me draw a little graph over here. If I have a line parallel to the x-axis, that means here's the x-axis, right? That's a horizontal line. And I need to know that horizontal lines have equations y equal, and then it's whatever the y-coordinate here of the point that the line goes through. Well, if I'm at 0, 6, let's say this is my line right here, and I'm at 0, 6, that goes through the y value. The y value for that point is 6. That's what it means to have a y-intercept. X is 0, y is 6. So my equation is just y equals 6. Again, just like I said on 41, 43, you got to have this, you got to kind of be thinking about these kind of things. See, I drew a picture. If it said it's parallel to the x-axis, well, what does the x-axis look like? It looks like that. Oh, I'm talking about a horizontal line, and I have to know that horizontal lines have equations y equal. Don't forget, you could use your graphing calculator and put in like something like y equal 6 or y equal anything, and just see what it looks like to remember that it's a horizontal line if you forget. And then you'll know, oh, if y equals a horizontal line, a vertical line must be the other one, x equal. And the number that goes here is always, if it's x equal, that means x is always the same, so you just take the x value off your point. But here it was y is always the same thing. So if my y value was 6 here, it's always going to be 6, and that's why we write the equation y equals 6. Y is always 6. Okay, looking at 45 here. I might go back up after this if we have time. It has an x-intercept of 4, and it has a y-intercept of 3. All right, there's a couple ways I could do this. I'm just going to choose one way here. Now, I know that these are intercepts, but they're also points, aren't they? For example, the x-intercept means x is 4, and it has a y value of 0, because the intercept, when you're looking for an x-intercept, the opposite variable is always 0, means y is always 0. And a y-intercept would mean that x is 0, and y is 3. The y value they give you here, okay? So now I could do a couple of things. One thing I could do is find the slope. That might be a fast way to do it. I can think of several ways to do this. Probably about 4 or 5 just right off the top of my head. So with the slope, if you remember, we're going to subtract our y's on top, and then we're going to subtract our x's on bottom. And if you remember, we have the y-intercept. That's a b right there. So what I can do is I can say I'm going to use y equal mx plus b. I'm going to use these 2 points to find the slope, and I already know I have a y-intercept of 3. That was right here. So let me go ahead and put plus 3. And I already know that I'm going to have a y equal, and I just need the slope to put right in front of the x. So let's go find the slope, and we'll plug it in right in front of the x, okay? Well, if I'm going to do this, let me label my points. I'll call this one x1, y1, and I'll call this one x2, y2. It's the second point, x of the second point, y of the second point. All right. When we find the slope, we're subtracting values on top and it's subtracting on bottom, and so that might be helpful to put down. We're saying y2, which is 3, minus y1, which is 0. And then on the bottom, it's x2, which is 0, minus x1, which is 4. Well, 3 minus 0 is 3, and 0 minus 4 is negative 4. This is my slope right here, and all I got to do to finish this up is go stick it over here. It had 3 over negative 4, but I could put the negative on the top if I want to, or I could put it even with the fraction bar. I could have left it on the 4, but either way, this is our equation for 45. Okay, I'm going to backtrack a little bit. No, we're just going to stop the video right here.